In this video, we are going to discuss the Thevenin theorem. So, Thevenin theorem states that in any linear bilateral active circuit containing several sources and resistance can be replaced by just one single voltage in series with a single resistance connected across the load. Okay, this is the simplest statement. So, Thevenin theorem is applicable to the circuit which contains several sources, maybe voltage source or current source, and contain linear bilateral elements, active circuit. Okay, so from the Thevenin theorem, what we can know is if there is a complex circuit, this is a complex circuit, and we want to find out current flowing through a particular resistor. Okay, so let's consider this is the terminal where the resistor is connected like this. Okay, and this is named as RL, we name it as RL. Okay, so we want to find out the current flowing through this RL. Then we can replace this complex circuit by equivalent Thevenin network. Okay, by equivalent Thevenin network. Equivalent Thevenin network. Okay, so this equivalent Thevenin network is look like this. So it will have a resistor in series with a voltage source. Okay, and this is the terminal where RL is connected. Okay, and this resistor is known as equivalent resistance of this complex circuit, that is R Thevenin, and this voltage source is known as VTH, and it is the open circuit voltage of this load resistance terminal. Okay, so when we apply Thevenin theorem, we will go through three types of networks. Okay, first one is network containing independent source only. Second one is network containing both dependent and independent sources, and third one is network containing dependent source only. Okay, so now we are going to discuss the steps to be applied when we solve a network containing independent source only. Okay, so first of all, we have to name the resistor whose current is required to be find out as RL, or in the question the RL may be given. Okay, then we will remove the RL and we will redraw the circuit. Then we will find out the Thevenin resistance or equivalent resistance at the terminal of the RL. Then in order to find out the equivalent resistance, all the voltage source will be replaced by its internal resistance and all the current source by open circuit. Then we will find out the open circuit voltage VOC at the terminal of the RL. So in order to find out the open circuit voltage or VOC, which is equal to Thevenin voltage, we can apply any methods. Then we will draw the Thevenin equivalent circuit and reconnect the load resistance, that is RL. Then we will find the current flowing through RL. Okay, in this problem it is asked to find out the current flowing through 3 ohm resistor applying Thevenin theorem. Okay, so in the first step we will name this 3 ohm resistor as RL. So first we will name it as RL. Then in the next step we will remove this RL. So we will redraw this circuit again. Okay, we can redraw the circuit as like this. Then in the next step we have to find out the Thevenin equivalent resistance. So in order to find out Thevenin equivalent resistance at the terminal AB, we will redraw the circuit and we will replace this 4 volt by short circuit. So its internal resistance is 0, so it is replaced by short circuit. And again this 6 volt is also replaced by short circuit. So this is terminal AB and this is 4 ohm. This is 2 ohm. This is 2 ohm. And again this current source 2 ampere will be replaced by open circuit. Okay, we can redraw like this. So here what we can see is this circuit is an open circuited one. This circuit is open circuited one, so no current will flow here. Okay, that's why current will only flow through this part only. Okay, so from here we can see that the equivalent resistance can be calculated as R equivalent at the terminal AB can be calculated as 4 ohm parallel with 2 plus 2. Okay, so here this 2 resistor is in series, so finally we can find out 4 parallel with 4, so it is 4 by 2, so it is 2 ohm. It is 2 ohm. Now we can write RTH equal to 2 ohm. Okay, then in order to find out the Thevenin equivalent voltage from this circuit, we will redraw it as, so looking at here we can see that this part is open circuited, so this part is no current will flow through here. That's why we will calculate the current flowing through 4 ohm because of these two source. Okay, this one and this one. Okay, so in order to find out this, we can calculate part of the network only, and if we know the current flowing through this 4 ohm resistor, then we can easily find out the voltage drop at this terminal A and B, that is VOC. Okay, so the volt at this part, the voltage drop will be voltage drop at 4 ohm resistor minus the source, this 6 volt. Okay, now let's solve it. So first we need to redraw it. So in order to find out the current flowing through this 4 ohm, we can apply nodal analysis. So this node voltage is named as V1. Then we can assume current I1 in this direction, I2 in this direction, and I3 in this direction. Okay, as per our convenience. Okay, then applying nodal analysis, at node 1, we can write the KCL equation is I1 equal to I2 plus I3. So then we can put the values I1 equal to B1 by 6, I2 equal to 4 minus B1 by 2, and I3 is 2 ampere. 2 ampere. Okay, then we can simplify it. So B1 by 6 plus B1 by 2 equal to 4 by 2 plus 2 equal to 4. And it is 6 B1 plus 3 B1 equal to 4, implies it is 4 B1 equal to 6 into 4 plus B1 equal to 6 into 4 by 4 equal to 6 volt. Okay, now we find the value of B1 as 6 volt, and we already know that I1 is the current we need to find out. Okay, so I1 is B1 by 6, so we can find 6 by 6 equal to 1 ampere. Okay, so value of I1 is found out as 1 ampere. Then looking at this circuit, we can find out the value of voltage drop at 4 ohm resistor is 4 volt. Okay, then finally VOC is come out as 6 minus 4 into 1 ampere. Okay, so this is 6 minus 4, it is 2 volt. Now VOC is found out as 2 volt, where positive terminal is at B. Okay, then we can redraw the circuit, that is the equivalent Thevenin network. Okay, so equivalent Thevenin network will be like this. So this is A, B. So at the B terminal, positive will be at the B terminal. Okay, so it is 2 volt. This is B Thevenin. Okay, here VOC is equal to B Thevenin. Okay, we have to know this. Okay, then this is R Thevenin. It is found out as 2 ohm. 2 ohm. Now we will reconnect the load resistance, that is RL. So RL value is 3 ohm. Now we will find the current flowing through it. So current will be in this direction. Okay, so IRL or IL equal to, this is VTH divided by RTH plus RL. So it is 2 divided by 2 plus 3 is equal to 2 divided by 5 equal to 0.4 ampere. Okay, therefore the current flowing through 3 ohm resistor is 0.4 ampere. Okay, like this we can find out the current flowing through any branch or any resistor by applying Thevenin theorem. The advantage and the disadvantage of Thevenin theorems is, when we discuss advantage, we can say that it is applicable to linear bilateral active network, and a complex circuit is replaced by a simple circuit, and it makes easier to find the action of the load resistance over the whole circuit. Okay, in the disadvantage, it is not applicable to non-linear and unilateral element containing circuit, and also it is not applicable to the circuit containing magnetic couple to load resistance. Okay,